I want to describe in very simple words and obvious terms concept of mechanical power that is used to describe mechanical lung ventilation. And I want to describe it in like very simple words for everybody be understandable because this term came from physics and like it can be not obvious for those who study respiratory care in a university. So I want to start with a very simple example. So assume that you have to push some trolley from point A to point B, um, and you need to spend some work to push this trolley from point A to point B. So this exactly described as work. So it's in physics term that is equal to multiplication of force on length, how far this force is implemented. So it's called letter W, it's equal to F multiplied L. For example, if we have to put it twice longer, so we will have obviously twice work. So we implement the same force but at twice distance, and it will be 2 multiplied work 1. Another example, if we have to push trolley to some hill, we'll have to spend a little bit more force on even if we want to push it to the same distance. So assume that we have to implement twice value amount of force, and it will be force 2 multiplied length from A to C, and it will be force 2 multiplied on 2 on distance, and it will be 4 times more than if we just put trolley from point A to point B. I hope it's clear now. So the main idea is just work is how much force do we implement and how long do we apply it. So this is quite obvious. At the same time, if we just leave our trolley here, so it will be obviously it will go back and it will be work of gravity forces. So gravity makes totally the same work as we do, and it will be calculated the same way. So it will be force of gravity multiplied how long this force works. So it means that we may have not only like we can measure not only work that we do, but an environment can also do some work. Also, if we assume that we have different surface, so for example, like surface more rough with some unevens and some more difficult things to move. 1 second. Yeah. Then we will have to spend obviously more force, because like we need to do something more. So why? Because our applied work goes partly to lifting the trolley and partly we work with resistance forces. So this is not all our work is productive, so we have to deal with some resistance in environment, surface, maybe it's we do it underwater, we have to work against water resistance, etc. So and mainly work of these resistance forces that can be like different of them. It's resistance of air, resistance of surface, the resistance maybe it's brakes or wheels are not well enough. It's usually goes to heating and some deformation. So assume that you want very fast to move this trolley through this surface. There is a risk that you will break some wheels, or if you go very fast and very often here, it will be heating with some time, so your wheels or tires will be warmer. So this is work of resistant forces. Usually it's goes for heating and some deformation of everything, of surface, of wheels, everything. This is about work, so I think it's also clear. So we have force is work is multiplication of force and length. We have a work of an environment, so something that resists us to implement, for example, to lift the trolley, and mainly this resistance work transfers to heating and deformation. So important that work is measured in joules. You likely know that joules is also measured energy. So by default, implemented work is energy that we transfer to the system, and part of this energy goes to heating and deformation. So work is the same as energy. So we can say that how much energy do we induce to the system to move a trolley from point A to point C. Also, there is a term called power. If we divide work that we did to move trolley from point A to point C for some time, we get power. And this is obvious that the faster we move our trolley, the more power we need to spend. So if we lifted our trolley for 10 seconds, we spent like work divided by 10 seconds. And if we did it for 5 seconds, power 2 will be the same work because we moved the same trolley for the same distance, but twice faster. And that's why we have to spend twice power, so 2 times more power. This is concept of power. Why do we talk about some trolleys and other things if we wanted to talk about mechanical lung ventilation? Because by definition, pressure is a force divided to some square. So it is obviously that if I want to make a hole, so it's assume this is some surface and I have some knife or needle and I want to make a hole here, I need to make edge as narrow as possible. So this case I'll be likely able to make a hole, and if it's if this square is too big, I won't be able to make a hole. So when I reduce square, I increase pressure. So with same force, I can introduce more pressure and make a hole in some surface that I want. So this is why pressure is equal to force divided by square to which this force is implemented. And more obvious regarding volume. So obviously, if we have some object with length, we increase its square, and obviously volume grows. So this is definition of terms pressure and volume. And now if we take our initial equation, like work is equal to force multiplied to length, and we divide it by square to which it was implemented and multiplied it to square of the object, we changed nothing, so we divided and multiplied on the same value, and it will be equal to pressure multiplied to volume. So work, what is equal force multiplied to length, it's the same as pressure multiplied to volume. So when we talk about lung ventilator that pushes air into the lung, it's totally the same as somebody pushes trolley to the hill. Force is prototype of pressure and length is prototype of volume. So that's why the same physics and the same terms regarding like power, work are applicable to description of mechanical lung ventilation. So that's what we get. Mechanical power is, by definition, pressure multiplied on volume and divided by time during which this pressure was implemented to this volume. This is basically what I wanted to describe. So I hope it a little bit more clear now. So where from this term appeared and why we can use formulas from physics to introduce it. And next time I would like to show how to calculate mechanical power in lung ventilation and why do we need PV loop for this. Thank you a lot. I hope it is now a little bit more understandable, and if you have any questions or suggestions, ideas, please ask. I want to make these videos as better as possible.